All right, let's crush another chemistry question. This one says, write the total ionic equation for the mixing of nickel nitrate and sodium sulfide, both aqueous. So what we're going to do is break these compounds up into their ionic form. So we'll start with nickel. Nickel is a transition metal, and sometimes transition metals can be tricky. It's going to have a +2 charge in this instance, and we can be sure of that because it's paired with nitrate, which has a -1 charge, and there's 2 of them. So to balance that compound, nickel must have a +2 charge. And we'll take our 2 nitrate ions that each have a -1 charge, and we've written this compound in ionic form. We're going to do the same thing for the sodium sulfide. So we'll have a sodium. We'll have 2 sodiums actually. Sodium is always going to have a +1 charge. And that's paired with sulfur, which must have a -2 charge. It's paired with 2 sodiums, and we'll write our other side of our equation. So this looks like a double replacement reaction to me, where one element is going to hop on with another one, and like the ions will kind of switch places. So what happens here is we end up with nickel and sulfur. Well, if we take a look at our solubility rules, which are important for these ionic equations, because if something ends up being a solid or non-soluble, it's not going to break up into ions, and sulfides are examples of those types of compounds. So nickel sulfide is insoluble because sulfides are typically insoluble unless they're paired with group 1 elements, which sodium is, so that's why sodium sulfide was aqueous. But this is going to be a solid, while the rest of these things are going to be aqueous. And the other 2 ions will stay as ions, as aqueous ions in our net ionic equation here. So we still have 2 nitrates with the same charge, that -1 charge, those would be aqueous, and 2 sodiums with a +1 charge, and those are aqueous. And that right there is our net ionic equation. Bunch of ions and 1 insoluble compound.